Coming up on This Week in Radio Tech, Mark Persons is with us. He's a mentor to radio broadcast engineers, and this week he's mentoring Chris Tobin and me about AM directional systems and the best practices for troubleshooting and taking care of them. It's coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, savings, and support. Online at bgs.cc. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by the CalRec Type R console system. Type R is a brand new, modular, expandable IP-based radio system from CalRec Audio. Hey, welcome into This Week in Radio Tech, episode 478. It's the show where we talk about everything from the microphone, we do talk about that from time to time, to the light bulb at the top of the tower. And this show, we are talking about something much closer to the light bulb at the top of the tower. Hi there, I'm Kirk Harnack, your host. Delighted to be here. We've been here over 10 years. Took a summer off, so we're not quite at 500 episodes, but we're getting there. We'll get there this year. I'm in my usual studio here, the Telos Alliance studio. I know, look at all the stuff behind me. Is this too much? Seriously, is this too much? I've really gone out for signage. Sometimes I think, maybe I should just return to the plain back wall here and not all the lighted stuff. But people give me and sell me all these cool things, and it's just it's humbling. It's neat. Hey, so I'm here in Nashville, Tennessee, in the Telos Alliance studio. Lots of Telos gear all around me here, intercoms, IP stuff. It's just great. And thanks a lot to Telos for giving me an hour off on Thursdays to do the show. Also here with us, checking in from somewhere in the heavily populated, densely populated northeast of the United States. It's former bomb diffuser, Chris Tobin.
Oh, hello. Yes. just enjoying a periodical. Why not? I'm reading, so I'm not using a tablet. Oh, boy.
Which one were you reading there? Were you reading the one that's got our guest's article?
Paul, it's the Radio World. Let's see. I didn't get a chance to finish. It's dated the 22nd of January. Oh, well, you've got, okay, so I've got, by the way, Chris, hello, it's Chris Tobin. Glad you're here, buddy. So what I've got, and maybe you can follow along at home if you've got yours, this is Radio World. We love Radio World from January the 8th. January 8th. It's the one that has hotels leave the light on for audio, and audio explosion reverberates in radio. And if you turn in this edition to page 18, it says right there, best practices for AM directional systems. And since I've never had an original thought in my life, I saw this article by Mark Persons. I said, right there, there's a TWiRT episode guest if there ever was. We should get Mark back on.
If there ever was.
Talk about this. Yeah. Let's bring him in. You've heard his voice, and now you'll see his face. Mark Persons. Hello, Mark. Glad you're here.
Well, good to see you guys. And as I was thinking, yes, in the last exciting episode of this TWiRT series, we alluded to the fact that that I was writing an article about AM directionals. And you might remember I said, if you don't know a lot about them, don't do anything until you read my articles. Of course, that article took like 4 months to get there. So I can just imagine quite a few AM directionals out of tolerance all this time.
Exactly.
But, so we should talk about that. We on our last go around, we talked about office desks. Do you by chance have that photo available?
Well, let's see. Let's see if we can just jump right to it since you've mentioned it. Suncast, there we go. There we go. Now, okay, that's not you sitting in that chair. That's a whole lot prettier than Mark Persons.
That's right. That's Paula. Now, let me explain that just a bit there. Those desks are at keyboard height. There are no keyboard drawers. I designed these desks, took them to a designer, to a builder who builds desks, and put it together. Now, you can't see it very well, but on the right-hand side of her desk, to the right of those brass drawer handles, that's where the computer is nestled. Its face is out, and then the back end of the desk is completely open. So that computer can breathe very nicely. It's out of the way. It won't get hit by a vacuum cleaner. It doesn't use up real estate on the top of the desk. It was an ideal solution. Did you also notice there's a 45-degree corner there where the keyboard is? That makes
Yeah.
so much sense.
Oh yeah, it does.
And you
It
can
does.
only do that with a custom design. And mine is the one in the background there, and it's pretty much the same. And oh, by the way, we moved them across town 15 years ago, and to do that, we had to disassemble them into half a dozen pieces each one. They're screwed together modules that that were reassembled on the far end. That was quite an
Wow.
interesting experience. And since then, we replaced the carpet, and then they had to be disassembled and reassembled one more time because they
For the
don't
carpet,
move
right, yeah.
out of the room.
Yeah. Yeah. Wow. Well, thanks for a look into the custom. You know, you do a lot of things very purposefully, very thoughtfully to further the business, which you've now retired from. So, are you using this office very much?
Oh, absolutely. Many hours a day.
You haven't retired, have you?
I should tell you also that these desks are islands in the room. And so how do you get wiring to them? Well, they come up on 3 conduits out of the floor to each one of them. Okay, so one conduit is for regular power, one is for UPS power, and the other one is for data and telephone.
Now, how did you get, did Paula have a problem? Because you know the stereotypical response, and it's usually women, but sometimes it's men, with, well, I don't like the sofa over there. Can you put it over there? Oh, no, I guess I liked it better over there. You had to decide where these desks were going, and that's where they had to be.
Well, we did it as a partnership. I mean, really, I get half the office and she gets the other half, and it really has worked out. We've operated in this office as corporate employees. And at the end of the day, 5 o'clock, we walk out of the office and we become man and wife again. But until then, we're working in a company, and it hasn't changed a lot. We're just involved in 1,000 things, and the desks and the office are perfect. And did you notice each one of the computers has 3 monitors?
I did.
And we just can't live without them. Or I could live with 2. But 1 is way too few.
You know, I got 3 monitors here, but they're on 2 computers. I got 4 monitors here. Well, 5. Oh, 6. Anyway. Hey, we're going to get to this AM directional troubleshooting and adjustment stuff. The meat and potatoes. We're going to get to that here in a minute. I got to mention, and Chris Tobin knows about these because he uses them himself, MaxConnectWireless.com. This is a modem. It's an ordinary cradle point modem, but it's no ordinary service, because with MaxConnect Wireless, you, the broadcast engineer, you get priority data, priority over everybody else on a given tower except for first responders. And that means you can be at a parade, a ball game. You can have a whole ball game full of fans in the stands, and you're trying to do your broadcast. And if you're trying to do that on a standard, MiFi or some kind of a hotspot that comes from a carrier, hey, come halftime, or everybody flips open their phone and starts texting or sending pictures and having FaceTime conversations, your data can just go to crap. So, can I say that? So Max Connect doesn't suffer from that. You get the data that you're guaranteed. You get priority. You get your own channel of data. And this particular one, this is set up for 5 megabits per second up and down. And by golly, you get that. I mean, you not 2.5, you get 5 megabits per second up and down. And my experience has been basically every packet gets there. Every packet gets there and back. MaxConnectWireless.com. Check it out. A broadcast engineer named Josh Bone came up with this idea, and he worked tirelessly with the different carriers, Verizon, AT&T, and now T-Mobile, to give you this service. MaxConnectWireless.com, and check it out. It's ideal for it. Hey, an emergency STL system for your transmitter site. Yeah, you can run audio through it. When Chris or I are on the road, we use Max Connect wireless modem, this one or Chris's, for our audio and video. And by golly, it works. It's just terrific. Check it out. You will be really happy that you did, and you'll find lots of uses for it, especially for remote broadcasts. Works great. All right, we're talking with Mark Persons. I'm Kirk Harnack, along with Chris Tobin. Mark, why don't we don't want to waste a lot of time. Why don't we just get right into it? You've got pictures and stories and instructions and advice on how to troubleshoot an AM directional. And I want to set this up just a little bit by saying there's so many. I believe there's a lot of AM directionals that are probably out of tolerance, out of whack. There's not an engineer there. And so sometimes a station owner will realize, man, I I got to get legal. I got to hire a contract engineer or somebody to come in and figure this thing out. I don't know if we've been taking meter readings. I don't know if it's correct at night. Sometimes it switches. Sometimes it goes off the air. Sometimes we just leave it in day mode. We got to get this legal before we get fined. And I got to believe that is not an untypical scenario. So, boy, it seems to me one of the most daunting tasks for an engineer is to walk into an unknown AM directional and say, and is told, make it right. Is that high on the scary list?
Yes, it could be if you don't know anything about AM directionals. As I pointed out in the article, and by the way, it's only part one of the article, so there's more to come. But the point is that don't do anything stupid. Don't start cranking on the phaser adjustments to make the antenna monitor right. Do a lot of observation.
I'm sorry, I got to stop you saying, because Chris Tobin's going to agree with me. The reason you don't start cranking on the phaser is because somebody's probably already done that, which is why it's messed up.
There you go. Well, that gives you the freedom to do that, doesn't it?
Well, maybe so. All right. So what should you do? You come in. What are some of the first points that an engineer would want to do coming into an unknown AM directional?
Well, first you want to write down all the readings, all the antenna monitor readings, phase and range tower, and the transmitter power levels and power. Excuse me, I'm getting a call that I don't want, and power from the transmitter, that kind of thing. So let me tell you that then the next thing to do is to go out in the field and actually take monitor point readings. And what's wrong with it's not catching up with me very well here.
Hey, tell you what, how about Chris and I chat for a sec? You reconnect, and we'll continue with the conversation. Chris, maybe get your advice on something, Chris, because you've probably come across this. When you have antenna monitor readings that, from the antenna monitor at the transmitter building, and this is what takes a sample, right, from each of several towers, how can you kind of assure yourself that those readings are right? How do you know you don't have a busted sample loop or a busted sample line or sampling coil, as so many people use? What may be a good indication for that, Chris?
Well, if you're fortunate enough to be at a site that's documented that information over the years, you can use that as a reference. Another thing to do is you can look at the basic formulas you can use, common sense, but you can look at the monitor point, the sample voltages, and say, the license will tell you, if you're directional, the license will tell you what things should be. So you can look at that to get a reference point. Also, as Mark was about to say, you should go out to do your monitor point readings is one thing to see if the pattern exists the way it should. Second, you should go out to the physical towers and record the current at the meters so you have a reference there. Because you could be, intolerance as far as a pattern is concerned by a certain amount, but you'd be running a hot tower, but somebody may have compensated for that difference. These are things I've come across over the years with people I've worked with, and they're like, oh, look at that, that's not right. So that's the way to look at it. And and the reason you don't turn the knobs in the phaser cab is because you don't want to be out of tolerance. Even if you are, leave it where it is. It's pretty basic stuff. It's just common sense. Yeah, don't do it like you do with a computer. Oh, it doesn't work. Power cycle it. Oh, the phaser's not working.
Power cycling doesn't fix the phaser. Mark, have you ever had a power cycle to fix the phaser?
Your common point measurements, you want to make sure your phaser numbers are written down. The transmitter readings, even check your plate voltage, plate current, or if it's a solid state, plate voltage. Voltage, current, output, all these things, all these numbers, these parameters will help you to build a picture, create a picture of a snapshot of what's going on. So that when you make a change, and Mark could tell you this, you can make a change on one tower and watch 7 readings suddenly shift, or you can make a change on a change a cap or a coil on your phaser cabinet and watch 8 things change and go, what?
Yeah.
You can lose your place so fast when you start doing that. Before you know it, your common point's nowhere where it should be. Your transmitter is barking like crazy, trying to say my impedance match is gone, and I'm going crazy with its power output. I've got before you know it, you may have a cap explode in your transmitter tower, the doghouse.
Mark,
Yeah.
this kind of sounds like walking into a situation as I set up. You're almost a crime scene investigator. You got to look at all the evidence. You got to look at everything. Busted caps, coils that have fallen apart or melted. As you said, take the actual current readings at each tower, log those, and you got to get a picture of where you're at. Go ahead, Mark.
Oh, not all arrays have base current meters anymore. They should, because that's a second check, but the FCC deleted that requirement years ago. But the more meters you have, the more you can do troubleshooting to figure out if something's gone wrong and what would be the logical choice. But again, doing the monitor point readings, write everything down and then analyze it in your mind before you put your hand on anything. Thank you. And if you're not sure what you're doing, call in someone who knows more than that, because you can make things far worse. Now, you probably wonder, some people watching the show might wonder, well, why do we have AM directionals? Well, it was very simple. Back in the day when my dad got into broadcasting in the 1920s, it was easy. They only had one station on one frequency at any one time. You didn't need a directional back then. But just as soon as someone else wanted to put another station on that same frequency, all of a sudden, the second station had to protect the coverage of the first. And so that's the story. And oh, by the way, in Minnesota, where I live, all AM directionals point north to Canada because they're directing they're protecting stations in the rest of the United States. That's kind of an interesting thought.
Which means that there's a lot of transmitter sites situated on the south side of their town, so they can send the power to the north, cover their town, and who cares what gets on to Canada, right?
Yeah. And these directionals really are designed to work. You might put 5,000 watts into it, and in a null on the backside, it might be only 50 watts. I mean, they have to work to make these things go. And FCC requires that you maintain them. And if you don't maintain them, you could be in for a big fine.
So I got to ask you about monitor points. You mentioned that as one of the first things that you do. And my experience with monitor points tells me that urban sprawl and development can result in what used to be a clear monitor point now not being clear. Maybe new overhead wires. Maybe there's a new cellular tower some distance away that nobody caught in terms of detuning it. And your monitor point is poisoned. It used to be like in a null point or a minima, and it used to have a very low reading, and now it's got a very high reading. But it may not be because the array is putting out more power in that direction than it should. The monitor point may have gone bad. How do you look for and account for that?
Well, what you want to do is you want to go back to the original proof of performance and look at all of the points that were measured on that radial, that azimuth from the transmitter site, and go out and measure the dozen or 15 or whatever, and look at those and find out that the place with the monitor point is high and the other places are just fine. In that case, you file for a change of monitor point to a new location. But then, of course, there are the MOM proofs, the method of moments proofs. You're familiar with that?
I've heard of that, and I just don't know what that is. Can you give me the little thumbnail sketch on that?
Well, for a big chunk of money, I don't know, $5,000, or you can have a consultant come in, and he very carefully checks the monitor system and the self-impedances of the towers. So you've got a real good mathematical number of what this array is all about. Then he comes up with a new set of antenna monitor numbers, phase and ratio, as compared to the reference tower. And then you live by that, and you don't have to go out and measure monitor points anymore, even though you might go out and measure them and find out they don't work quite right anymore, but it's FCC legal, and it's actually a very good method of making the array work. And the nice thing is that the MOM proof that he does is good forever unless there are any changes. Okay, so let's say you add an antenna to your tower. Well, all of a sudden you're into new mom-proof. Or let's say that something went wrong and antenna monitor line went bad. You have to replace that while you're into another mom-proof because you don't have what you started with, the exact same system. But it's a nice out for places that have urban sprawls. Oh, that's the point, is these AM directionals, as you pointed out, were built on farmland years ago. Well, what are they now? Apartment complexes surrounding the place. Good grief. And all the power lines to go with it.
Hey, let's look at our first couple of pictures and jump right into the story that you want to tell about looking at an AM directional system. Suncast, could we get the second picture in the album? And there we go. I'm not sure that's one that you wanted, but that's one you got.
Okay. This is in Minneapolis. Steve Smith, let's see, it's a Salem broadcast company. And what he's got his hands on is a used phaser that came in from, I think, Seattle to add this extra station to his existing 4-tower array. Let's see, it was 900 something and 1280. Behind him is a Harris 50 kilowatt, which they run at 5 kilowatts a day. And get this, the power upgrade on 1280 allowed them 15 kilowatts at night, just because they're in a different location. And as you pointed out, the new location is on the south side of Minneapolis, and the nulls go south from there, and the power goes right through town.
Wow. Imagine that. Geolocation of your, selecting your transmitter site to put the power where you want it by picking the right side of town. Let's see the next picture, and we'll get a quick description of it. What is this? That looks old.
Okay, this is from my Radio World article, and it shows a 1960s phaser. It's the gray box on the right, and it has a couple of Delta toroidal ammeters on it, one for daytime antenna current, and the one on the right is for the nighttime common point current. Common point is where the transmitter feeds the phaser, and then the power is distributed at that point to the towers involved. Now, the interesting part of this article was that I pointed out that on the transmitter on the left is a Gates Harris BC5H, which I took care of for the past 40 years. Anyway, while Paula and I were in Santa Fe, New Mexico, terrible things happened. The transmitter destroyed itself, not like a huge fire, but here's how it happened. The engineer who followed me, by the way, a big shout out to hello, I'm not thinking today. Don't have a senior moment. You've got real problem. Jim Offerdahl. Okay.
Oh yeah, I know Jim. Sure. Yeah.
He's a wonderful guy, and he followed me. And you don't always check the air pressure switches on transmitters. I mean, I didn't do it. I didn't do it every time.
I have failed to do that many times. So checking the operation of the air pressure switch should have.
And it got me a few times in the field, and gosh, it got him on this transmitter too. So it happens, and it's just a part of maintenance. If you remember to do it, you should check it. And how do you check an air pressure switch on a transmitter? Well, the easy way is to let a little air escape unnecessarily from, say, a PA cabinet. On this transmitter, it's in the back. There's a big plate that you put on the back that uses the Zeus fasteners. Anyway, the point is that you don't have high voltage on, but you got the filament on, and as the plate is pulled away, you hear the filament contactor drop out, and then because air is escaping in places it isn't supposed to, and then or the air pressure is too low to make to cool the tubes. On a Continental FM, it's a lot easier because you've got the front doors, and I always use the lower front door on the left, the driver door, and if I opened it 1 inch, that's the place where the filament would either would stop or turn back on as I pushed the plate back into position. So that's testing the the air pressure switches or air flow switches as another procedure for that. But the point is, it's all a part of maintenance. What happened was, when no one was looking, the transmitter fan blower quit and the air pressure switch didn't catch it. And in the article, I said, well, someday my successor is going to replace that transmitter when something happens. Well, guess what?
Something
It's
happened.
a good thing there was a backup transmitter to go there.
Well, hey, we're going to continue that story in just a minute, Mark. Mark Persons is with us, and we're talking about troubleshooting and maintenance of AM directional systems. We've got more pictures and some real nitty-gritty to get into with Mark. Chris Tobin is here as well, and I got to tell you about the real offer that's available to you as a TWiRT listener. I really appreciate you, and in appreciation back, I've worked it out with Mike Dosh at Angry Audio for you to get a free cable with every single one of these. That is a Studio Hub adapter. This is the kind of cable that has the female RJ, and it's got whatever kind of connectors you want here, XLR, male or female, or 1/4-inch tip ring sleeve. There's a couple other kinds as well, like RCA connectors. Anyway, every one of these you order, you ask your dealer, because this is not good for people who don't ask. You got to ask your dealer and say, hey, Kirk and Chris on TWiRT said, give me a free cable. And for every one of these you order, you get a free cable. And this is an absolutely fantastic, high quality Studio Hub certified patch cable. Even on the label here, it gives you the Studio Hub wiring in case you forget, which one's left channel, which one's right channel, which color to use for AES digital audio. But you got to ask for it. All right. So don't let that pass you by. If you order one of these, or 10 of these, or 50 of these, without asking for your free TWiRT cable, shame on you, because you're missing out. All right, these are the best quality cables. Do that and check out the website angryaudio.com, where you'll find all a lot of the Studio Hub stuff, the Studio Hub patch cables and RJ45 adapters. You'll find it all there, and some of the electronic stuff too. And they can supply a number of parts for Studio Hub gear. More coming up right after this word from CalRec. Hang on.
CalRec's Type R is a modular, expandable IP-based radio system featuring 3 slimline panels, a fader panel, a large soft panel, and a small soft panel easily configured to give the operator full control. Layouts are saved and recalled quickly between shows. A single 2RU core with integrated I/O gets customers up and running fast, and that single core can power up to 3 independent mixing environments with no sharing of DSP resources. Available in 4 DSP packs, and as your station grows, larger packs can be added, enabling it to grow with you. Power to the surface is supplied via standard PoE switches, keeping cabling to a minimum. Type R is fully AES67 compatible, as defined by SMPTE 2110, which means that it is also compliant with NMOS discovery and connection management specs. All these features combined make Type R the most flexible radio console you can buy. Find out more at calrec.com/TWiRT.
Thanks so much to CalRec for sponsoring This Week in Radio Tech. And yeah, there's the website, calrec.com/TWiRT. And that'll let them know that we sent you. Thanks a lot. Kirk Harnack here on TWiRT number 478. Chris Tobin is along here. He is somewhere in the New York City area. And Mark Persons is here from Brainerd, Minnesota, where is it cold there today?
Actually, we're mid-teens at night and in the 20s during the day, which is almost normal. We've been through our 20 below nights in early January and December, that traditional thing that we have in Minnesota.
So our next picture, Mark, is somebody with a hand on a knob called common point reactance. So what would this knob be doing for us?
Okay. Well, in the case of a tube transmitter, the one we just saw, the transmitter was tasked with running 5 kilowatts day non-directional, and then it was 5.4 kilowatts night. So the power control, so to speak, is on the phaser. The common point reactance will cause the transmitter to go up or down in power as desired to get the amount of power that you want. Now, that won't work with solid state transmitters. That's a different story. You'd have to assign a different power level, which is easy on solid state transmitters, not easy on tube transmitters, by the way. That's a whole different thing. So anyway, the plan was, and as I put it in the article, you turn the, you adjust the transmitter so it's making normal 5,000 watts during the day on the day pattern. Switch over to night pattern, make sure all the phases and ratios are right, then tweak the common point reactance so the transmitter says, oh, I'm going to make a little more or a little less power to get to my 5,400 watts. It was just an easy maintenance thing every time I was at the transmitter.
Okay. All right. What's next? We need to move on through these pictures because we got more to go. What's this phase center tower?
Okay. Basically, it's saying mark all of the phaser dials so you can go back to them in the future. You imagine walking into that building and you have no idea what's normal, and you don't even know where the phaser cranks should be.
Mm-hmm. So let me ask this: when you're cranking on a phaser, for those of us who are new, what are you turning behind the panel?
Oh, it's either a coil, usually a variable coil, could be a variable capacitor.
Now, those variable capacitors, they're pretty expensive. So I think when they design phasers, they try to have fixed capacitors and variable coils. Isn't that about right?
That's true, because especially at the 5 kilowatt and up level, you're talking vacuum variable capacitors. Mm-hmm. So, and you were talking a couple $1,000s for a capacitor, whereas a coil might be half of that. But it would also have a fixed capacitor in series with it.
What are some of the things that typically go wrong with these coils? I've cranked on some and heard a little arcing noise, or had things just shut off altogether. What's going on there?
Oh, well, they get dirty, they get cranky, so to speak, where the contacts, the dirt just makes them have bad connections. And of course, there's RF flowing through them. And as you rotate the contact point on the coil where you're going to pick up a different spot, all of a sudden you can have arcing. And once you've got arcing, then you've got carbon, and then you've got a bad connection. And things just go bad from there. So keeping things clean is important.
I never had to replace, maybe I did have to replace a roller, but these coils that have a crank on the front, you're turning the shaft down the middle of them, and that has a roller that's typically silver plated, and it goes around and around the coil, and the coil is a helical thing, right? It's wound, and you are tracing the track of this coil to either add more coil in the circuit or take away coil from the circuit, thereby changing the inductiveness of that coil. But it's a roller that does this, and you may have a pretty fair amount of current going from the contact of this ribbon coil into that roller, and that seems like kind of a weak point. Is there some kind of regular maintenance that one should do to make sure those rollers don't arc over?
Oh, well, that's a tough one. They just fail with age too. You just want to clean them. And by the way, I've actually taken coils out of devices like that, or phasers, and I have I've cleaned them, and I forget the name of the cleaner, but it's an acid actually, and it just gets all the junk off of them. And so you can put them back in. It's a several-hour procedure just to take one coil out and rework it. On my website, mwpersons.com, look under Tech Tips, and you'll actually find a procedure for doing that. They generally last a long time, but you're right. They could have a lot of current going through them. And by the way, those coils are rated in current. 15 amp, 20 amp, 30, 40, 50 ampere. And if you overdo it, you're gonna toast the coil, and then you're gonna have to put a new one in, because you get to a point where you can't repair them.
Yeah. Yeah. We often talk about keeping a log so you know where things are. And our next picture really depicts that pretty well. Let's have a look at that clipboard picture.
Okay.
There we go.
And that's the simplest of the logs. This is the day-to-day one. So it gives transmitters, PA volts and current, and antenna current. It shows the phase and ratio for the towers, and then it goes on to when you take the readings at the monitor points, and then what time of day you did that, and a signature, and all of that. But this is the day-to-day. But in the background, which isn't shown here, is the proof of performance measurement. It might be a 30 or 40 page document with all of the readings. And one of the important readings, or one of the things that oftentimes gets left off the list, is actually marking down the number of active turns on a coil as built. Now remember, you've got a design, and a factory might build a phaser, but when you put it in the field, where the phaser is tapped on the fixed taps on coils, those might change a turn or two. And what you want is an as-built result, so that if something goes wrong, you can put it back again. Oh, by the way, people think of buying phasers. I don't know how it happened, but I'm just the guy who works with his hands, and I built them. I built 5 of them. 4 of them were for brand new stations. One of them, a 5 tower on 650 kilohertz in Hibbing, Minnesota. Do you know the piece of land that tower site is on is 3/4 of a mile in length, north to south? And it's pointing north too, by the way.
Well, sure, it's pointing away from WSM here in Nashville at 650, just down the road from me, which is 50 kilowatts non-directional day and night.
Right. And for their 5 towers at Hibbing, Minnesota, they got 250 watts at night.
Wow.
10 kilowatts day. Later upgraded to 500 watts when the FCC's rules changed. But you're right. They had to protect WSM.
Well, they don't listen to the Grand Ole Opry in Hibbing, Minnesota. That's for sure.
but I live 100 miles south, and I can hear the Grand Ole Opry here without interference.
Because directionals work, don't they?
Yes. Now, if it wasn't working, I'd be listening to both stations at the same time, which would be a bad deal.
Let's take a look at our next picture, because this really, I think, tells a story. There's a lot to talk about right here. Why don't you walk us through this, what we're looking at?
Okay, this is from the Minneapolis project. I didn't do the project. I just wrote the article about it. But you mentioned the coils and capacitors. Bottom center with a black knob facing us, that is one of those coils. You rotate that knob and you're adjusting the inductance of that inductor. Now, to its left and to its right are another couple black knobs. Those are very expensive vacuum variable capacitors. But that's what the project took, and that's how they built it, and it worked. And by the way, you'll see some components that aren't connected. This was taken before all the connections were made, but it just gives you a good idea of what it's all about.
Why are some coils made with tubular material and others made with ribbon material wound on its edge?
Okay. It all has to do with surface area, and the ribbons are good for 15 or 20 amperes of RF current. If you want more, if you want 30 or more amps, then you're into tubular coils.
In the lower left of the picture, there's that red jumper across the J. They call that a J plug, and that's where a current meter can be placed, I suppose. But behind that, on the bottom, on the floor of this cabinet, there is, looks like a pretty high power handling toroid, or is called a TCT from Delta Electronics. Tell me about that.
That is correct. And you remember the picture of the phaser we looked at earlier had two delta common, well, one was a common point meter, one was an antenna current meter. They use TCTs, what's the toroidal current transformers? That's what they are.
Sure. Yeah, that's what it is.
Sure. And so that's what that one is there.
So, and I'm trying to go in my way back memory machine. TCTs, toroidal current transformers, can be used for measuring just the current to a single tower, to a non-directional AM station. But they can also be used to measure current and give you a reading of the phase at a given tower, correct?
That is correct. It's situation dependent. Some stations and situations require a current loop. It might be a couple feet long, foot wide, and it goes to a transmission line, and it samples what's on the tower. So it gives you that, you're right, that phase and ratio relationship to the reference tower. Every directional array has one tower that's the reference that you check or phase the others against. And it's usually the high current tower.
Yeah. Now, help me remember let's say you have a single tower AM station, non-directional. How did we remotely measure antenna current before we had the TCTs?
Oh, I just disassembled one the other day. It had a.
I think Chris wanted to say something. Chris, chime in if you don't mind.
That's all right. I was just throwing out thermocouplers.
A thermocouple. A thermocouple. Now, Mark, remind me what one looked like, or tell me the story. You said you're taking one apart.
Oh, well, I meant that I took apart a remote sample, but you're right. The thermocouple meter, it looks like an ordinary panel meter, just happens to read RF current. But if for remote sampling back at the studio, I thought that's what you were getting at. I had one that had a 6H6 tube in it. Get this, out at the tower. But of course, that goes back to the 1950s or before, and it sent a small DC sample to the studio saying, "This is how much current is going through the tower right now." And of course, it would require frequent calibration as well.
But in any directional system that's been built, in the last 20, 30 years, you're probably going to find the TCTs, which I love those things. They seem to provide really stable and accurate sampling.
What I like about the TCTs is they don't jump up with modulation. Okay, in a previous article that was on AM Sweet Spot, I mentioned that with the thermocouple meters, they will rise up. Why is that? Because the amount of power that a transmitter puts out, the average power, goes up 50%. So if you start out with 1,000 watts, you've got 1,500 watts that the meter wants to see. But in the case of the Delta TCTs, they somehow work around that problem, and you just see them steady. But you could see them drop a little during modulation. And why is that? Or maybe I should give the answer. Maybe.
Sure. Give the answer. Why?
Okay. It's called carrier shift.
Oh, okay. Yeah.
Okay. So a transmitter putting out 1,000 watts, and then you modulate it, and the power supply voltage drops, and so the transmitter doesn't put out quite as much power as it was putting out. So that's carrier shift. And I think the FCC limit on that was it 3% or 5%? But we just don't see that happening in solid state transmitters anymore. Just doesn't happen.
Yeah, they put out what they're supposed to put out pretty accurately. So, gosh, I had one more question about. I remember when I started in AM radio, we were supposed to take our remote current reading with no modulation. So of course, it was a top 40 slam banging radio station. Dead air was a bad thing. So we would have to wait till a newscast where the newscaster would say, "I'm Jim Chenevy. ABC News or whatever he works for. We'd have to wait for that pause and watch that meter go down and say, aha, that's the reading right there. That's it.
That's it. Here's a famous radio line. Here, you ready for this one? Coming up on Suspense Theater.
I don't know Suspense Theater. I'm sorry.
No.
Am I too?
No.
Oh,
See,
God. Oh my God. You got me. You got me. Hey, I wanted to let Chris know. Chris, we mentioned Jim Offerdahl earlier in the show, and I've been actually texting with Jim. Say hi, Jim. He started a watch party, so there's a bunch of people watching the show, and Jim Offerdahl started it all.
Okay. Sorry about that. I had a senior moment, but I got over it. So
let's look at some more pictures. We don't have a lot more time in the show, and I want to get to some more of these pictures. We got a picture of some towers here. What is this we're looking at?
This is the Minneapolis station with the 4 towers, where they combine the 2 stations. So all 4 towers are hot with the 2 stations.
Gotcha. And those are kind of tall. They're lighted. So I see Austin rings on the nearest tower, certainly.
Yeah. Well, it was built back in the 60s, and it's a 900-something kilohertz station, so they have to be tall. And guess what? They're aligned up north to south.
Yeah.
They're pointing from the south side of town. They're pointing right into, actually, the Twin Cities metro, Minneapolis, St. Paul.
And those Canadians get so much American radio, don't they?
They must.
All right, what's this next picture? It's a horrible, muddy mess. It looks like Army games gone wrong. What is this?
Yeah. Well, this was during the construction when they opened up trenches to run all the cabling to the towers. They were just deluged with a rainstorm that just put them behind. Boy, it was a tough mess. Steve Smith, if we got him on the radio, he could tell you the whole story. But it was tough. It happens sometimes. Wow.
I see a shopping center back there. I'm sure it wasn't there when they built the station in the 60s.
In the 60s.
Hey, we're going to take a quick break right now and come back. We're going to get a final tip or two from Mark and perhaps from Chris as well on the topic of AM directionals. And we're also going to have some fun. You would not believe some of the pictures we're going to run through here that come from the great north of the U.S. And there's some electronics here to look at too that I'm kind of impressed with. And we're going to finish the show with a man kissing a fish. So you don't want to miss that. This Week in Radio Tech is brought to you in part by our friends over at Henry Engineering. Henry Engineering is the maker of this awesome device, this one rack unit box. Every station needs one. If you go out and either do remotes or live sportscasts, you need this, the Henry Sportscaster Sports Broadcast Audio Control System. We had Hank Landsberg on the show to describe this last year from the NAB show. And this thing is it's really been well engineered after all. It is Henry Engineering. It's an audio control system for managing the audio portion of a sporting event, radio, or video broadcast, or both. It's when it's used with the Henry Sports Pods, the Sportscaster creates an integrated system that includes all essential audio functions, including audio mixing for air or webcast, headphone audio management and distribution, and off-air intercom. Yeah, built-in intercom. So, you can get people corrected. Bob, that number 52, his name is Charlie. Things like that. Sportscaster eliminates the need for multiple mixers, distribution systems, headphone amps, intercoms, power supplies, and a whole bunch of wiring. Sportscaster provides all these essential functions in a one RU package. It's so convenient. And you need to couple it with these sports pods. Your announcer gets one, the color person gets one, the spotter can get one, and then a producer, if you have a producer to help kind of keep things moving along, that producer has an intercom as well that can talk to the field reporter, the crowd mic, of course, the announcer, color person or spotter, all these things, so you can have a really well-coordinated show. You also have intercom that can go to a camera person if you've got that. If you're doing a high school or college based, small colleges might do this kind of thing. Lots of features, just a whole bunch of bullet points to go over. So I'm not going to hit them all, but this is just an amazing box. So well thought out and so well engineered from Hank Landsberg at Henry Engineering. You need to go to the website at henryeng.com and look for the Sportscaster. Where do you get a Sportscaster? Where do you get a quote and have it delivered to you? Where do you order it from? Well, go to my friends over at Broadcasters General Store. They are terrific. I talked to Jonathan Shute there just this past week. Well, I talked to him on email. And Jonathan and his whole team there that works with him, Carly and Jessica, and of course, Dave Kirsten is there. And if you know Dave, you know you can get a great deal. And Buck, tell Buck to sharpen his pencil. Call him at 352-622-7700 or visit their website at bgs.cc. bgs.cc. And hey, if the Henry Sportscaster isn't what you need, guess what? They got everything else at bgs.cc. Check them out. They are awesome people, and tell them that you heard about them on This Week in Radio Tech. I'd really appreciate that too. They're good people. I've had dinner with them many times. Good folks. I'd spend all day with them if they'd let me. All right, we're going to round out the last 10 minutes or so of This Week in Radio Tech. Mark, tell you what, do you have any last minute advice that you really hadn't gotten to? Anything that comes to mind that says, hey, what's essential about an AM directional system from maintaining or troubleshooting it?
What we haven't covered today is what you'll find in part 2 of the article in Radio World. So watch for that.
Well, what a tease you are. Okay. And here on the show, we speak jovially. I got to tell you, if you'll pick up the January 8th Radio World, and you mark your articles online now too at radioworld.com, right?
Yes,
I think I saw it online. Yeah. So Mark it writes his articles with incredible clarity and purpose of words. And I say that in a very complimentary way. He's an expert at conveying the information you need. And we've spoken jovially and fun and looked at some pictures here. But if you go read the article, you want to be up to date on some techniques for solving AM directional problems. There you go. Hey, we only got a few minutes. Mark, let's run through these pictures. Chris, man, you need to pipe up and comment on these pictures as we see them here. What is going on with this?
Yeah. It's called polar plunge. People do that in Brainerd, Minnesota. That's a lake they're on, and those are scuba divers protecting them.
Oh, good God. Oh, gee, what's next?
It's a fundraising thing, and this is what they look like when they come back out.
This lady fell in and she's cold.
Yeah, Jesus.
How cold is
what's
that?
The air temperature at that time?
Okay, this is a $150,000 fishing contest on Gull Lake at Brainerd, Minnesota, an annual thing. The money all goes to charity. There are 10,000 holes in the ice out there, and it's a Brainerd JC's project.
Chris asked, "What's the water and or the air temperature that woman was coming out of in the previous picture?"
Well, the water temperature is right at 32.
Yeah.
If you think about it, there's ice on top. So it's, and the air temperature, well, it could be, typically when this is done in March or February, it's usually above 0, but sometimes it's below.
Oh, gosh. Oh, man.
Okay, good.
Yeah.
Good.
How do they keep their clothes from freezing when they get out? Are there warm blankets waiting? Is there a warm room waiting?
There is a warming tent just a short distance away.
Glycol. Drink some glycol. No, don't drink some glycol. All right, so let's go back to that picture with the scoreboard, and let's go back one picture because I want to see it. What's the electronic scoreboard? Is that to keep track of who gets the biggest fish?
That's right. And so they keep updating it, and it's huge. They must have spent a fortune on it because basically it's a bunch of video screens or big videos. Yeah,
video screens, and look at all the porta potties. My goodness, you want to use that and not the hole in the ice.
No kidding.
Yeah, 150,000 people on ice.
Yep. But
wow.
Now it's $150,000 with
dollars.
About 10,000 fishermen, and they don't allow cars on the ice except for support vehicles. Yeah. So their people are bussed in.
So what's the Suncast, what's that next picture with the people dressed up? What is this?
They like to dress up and just be wild. So, it's a show off time too.
Now the helmet that he's wearing with the horns, is that a directional antenna as well?
Well, it could be for higher frequencies, but quite frankly, we're in Viking territory here, and so here's some muskrat hats or whatever, just more of the same.
Gosh. I wondered which of those horns was
dresses up like a gorilla or a
Yeti.
Sasquatch.
Yeah, Sasquatch. Oh, gee, what's next? Oh my goodness.
This was the winning fish. Get this, is an eel pout. It's an ugly fish. Nobody wants one, but this guy caught one that was over 8 pounds. But he was so happy because the biggest fish caught to that point halfway through the contest was only 3 pounds. He knew in the next photo that he had won the big prize, which is a pickup truck. He knew at this moment that he was going to drive home in a pickup truck.
Wait, that ugly fish got him a pickup truck.
That's it.
Chris, you want to meet up there in Minnesota and give this a try?
Yeah, I think we should go that next year. Why not?
I could use it. I could use a pickup truck.
March. Yeah, it's full time.
Wow. Oh my goodness. And I think we had one more shot. I'm not sure what it was, but you wanted to include it. Mark, who are these folks?
Oh, well, ladies compete too. So just part of the whole thing.
Now that, excuse me, but that's a pretty short little fishing rod right there. Is that rod and reel set? Is that what they look like?
You don't need much. You just drop your bait through the water. Remember, you're just fishing through a little hole. It's not like you're casting someplace.
Oh, you're already right over the fish, aren't you?
Yeah.
Wow. Oh my goodness. So Mark, I got in, I know we covered a lot of the topics here and a lot of basic stuff. If you want some more details, get this January 8th Radio World, or go online to radioworld.com and look for you can just probably Google the title of this article, Best Practices for AM Directional Systems by Mark Persons.
Yeah, part 1. And by the way, you made nice comment about my writing. I've become a wordsmith. I write better than I ever speak in public because I go over and over and over it. I probably go through the script 20 times, smoothing out the bumps, getting rid of the extra thes and the ands, compressing it to be just right.
And it shows. Thank you very, very much for that. I write something once and say that's good enough, and then of course the editor makes his corrections. Chris Tobin, we've been yapping here, and I know you've got Chris. We could probably go a couple more minutes. You've got AM directional experience up there in the New York City area. Has your experience in New York City area been different, or do you have something to add to what Mark's been telling us?
No, it's been about the same. It's pretty common what you come across. I mean, I did have one site that was 5 towers in line. It was all swamp, and it was interesting when you go out. Twice a month, I'd make sure I go out to the site. You never knew what was going to come jumping out onto the walkway, the wooden planks that connected the towers, and sometimes at night you'd hear things in the high grass and be like, "Oh boy, here we go again." And there were times I'd look down into the water. And you'd see things swimming around like, what the heck is that? And if I could grab a picture of it, I would, but it was interesting. We did have one site I worked at, we had low tide, and low tide came, and it was interesting, some of the things that were sticking up out of the mud. It was a bicycle, motorcycle, there was a few other things we found. I was like, wow, that's pretty good. AM sites are known for their interesting antiques that you find. And it's interesting, some of the folks you bump into also, if your site is in a real rural area, which I've had a few, they're out hunting and doing things. You're like, this is going to be a good one. Yeah, I've had a few of those moments. It's fun. Or you take monitor points in somebody's front yard on a stone, because that's where it's been for the last 50 years. And they come out going, what are you doing out there? Like, oh, sorry, I thought I was on the sidewalk. I had one site, we had that. It was a rock. It was labeled. The previous engineers before me, which was a 50-year station, marked in the rock. They made little markings, that little metal plate. The property owner one day said, "Yeah, I never knew what the heck that meant, but every so often some guy comes out with a box and he stands on it and he spins and then he leaves."
He spins and he leaves.
Let me explain to you how that goes, and so you don't shoot me, because he's on his porch with a long arm, I'm like, dude, we're good. But his once I told him the radio station, he was like, oh, it's you guys. Oh, great. Comes out with a little lemonade. I was like, oh, this is good. I like this. This is good. But yeah, it was the best description though. Yeah, a guy comes out with a box and spins on the rock and leaves. I'm like, well, it's a special ritual we all do once every 4 months.
We have 12 such places around town. We do that.
Yeah, I didn't tell him about the other 3 that I had to go to, which were in a cemetery. That was the fun one, the cemetery. Oh man, that was a doozy. I used to have to call in advance, and I hope I got the right caretaker who remembered why we come out, and we walk along the pathway, go in the back, and it was by this tree. And it was just it was fun. Yeah, but AM directionals are an art, a craft, black art, and I would if anyone is recently come across employment as a directional AM, I will say 3 things: observe, document, and observe your site at least twice a month. And if you have sample loops on the tower itself, make sure they're still there when you come by after a major storm, for those of you in very stormy areas. Also, if you have above ground transmission lines between towers, walk the lines at least once a quarter. Make sure nothing's sticking out of them or they're crushed. And was just, as Mark pointed out, just document everything. Check those readings. You'd be surprised if you overlook one thing and it'll come back to bite you. But that's with directional AMs. You got to kid gloves. You got to make sure you pay attention, and I mean really pay attention. And don't just start tightening screws on things either. Be careful. Just if it's working, leave it. Just observe it, make note, and move on.
I'm going to ask one more question of Mark because it kind of bothers me. I've never had to work on an array with more than 4 towers, and to me 4 was enough. And luckily, my whole tenure there, which was close to 10 years, nothing bad ever really went wrong except for the controller. It was a custom built with some ICs in it and relays, and I had to replace a few ICs. I got used to that, and that was okay. But if you come across a multi-tower directional where everything just seems really out of whack, Mark, do you just look for the tower? Do you start at the tower that's got the worst reputation, the worst readings, and really look for a physical problem there? How do you start to isolate a problem that affects everything else?
It's a 2-man job. One person is pushing the button to change between day and night. The other person is out at one tower at a time looking, okay, is this thing switching or what? And then you go out there and you look for loose connections, that kind of thing.
Exploded caps, brown marks on coils.
Yeah. Okay. This is
even
where
the RF switches. If you're changing patterns, even the RF switch, you have to look at the finger stock. I worked at a place where the relay was switching. The rocker switch went like it should, and nothing would happen. We're like, what's going on? The little finger stock that literally looks like this, with my hands cupped, was gone. So the metal bar that made the contact, was connecting to nothing. That's why when we switched pattern, the pattern didn't really go where like it should.
So what I'm hearing from you guys, and this is actually, the whole time I was doing regular full-time contract engineering, sometimes I described myself as a high-paid janitor because the biggest troubleshooting technique I had was to observe everything closely, or the things that were related to the problem I was looking for. And so often I would find, the high voltage connection to the tube in an FM transmitter, boing, had come off, some non-connection. And with an AM directional array, Chris, I'm glad you pointed out that finger stock on the switches. And sometimes the solenoids would get stuck or slow to move, that kind of thing, that they should go ka-chunk, and move quickly and make great contact and those things. And if they get moved while there's RF applied, that's going to really decrease their life. So you want a controller that removes, shuts the transmitter off, makes sure that there's no RF, then makes the switch, and then applies the new power from the transmitter. Otherwise, you're going to get burnouts like that. So I'm glad you mentioned that. You got to go look at everything and look first for physical problems, and you're very, very likely to find what's causing the issue. Mark?
Well, yeah, I worked at a station. I used to make it my habit, but I did get to work at a station where it was part of the policy. Every quarter, we would go out, go off the air on the overnight and physically inspect each of the towers and all the electronics and the mechanics to verify everything was in good shape or look for any wear and tear that may be occurring. Basically, anything with moving parts, you got to be looking at. I mean, I just had a conversation with an engineer for a station here in New York City last week, and we were talking about how he has several about 8 sites around the city of New Jersey, and how they're fully automated, and his folks at Master Control can see everything that's going on. And I said to him, I said, yeah, but how do you keep ahead of like the blower motors or fans or air conditioning? He goes, oh, I go out to the sites at least twice a month. Yeah, no, there's nothing replaces a physical inspection. So I was like, okay, that's good. There's still some people doing that. So the AM sites the same way. It's even more with AM sites, but yeah. You got to do visual inspections. I don't care what anybody does. You can do SNMP up until you're blue in the face and have every parameter, every 10,000 parameters you want your site covered. If that HVAC or the blower motor or something goes awry, you won't get there in time for it because you didn't pay attention.
That's great. I'm glad you mentioned SNMP. A lot of things like this you cannot cover with SNMP. Mark, you want to give us a final word?
Well, I do have a tip for you, by the way.
Yeah.
You asked for a tip? Okay. So my tip today has to do with tie wraps. Okay. So you do a tie wrap, and what do? You snip it off, but some of the tie wrap is still showing. You see that?
Well,
I'm going to get that.
Not on my tie wraps, but you're going to show us how to do it right.
Okay. Well, anyway, you accidentally run your finger by there, and it tears your skin open.
You got blood now. Blood. Yes. You're a phlebotomist.
The plan is to use a pair of wire cutters and scrape across the tie wrap so that there's nothing here to catch the skin. But then I get out, if it's a portable application, I get out some of this super glue.
Oh, wow.
And I put it right into the tie wrap. And just a drop, that's all it takes. Let it dry, and that tie wrap will last forever. But it might otherwise come apart in a portable application.
That's a great idea. That is a great tip. Wow. Yeah. All right. Good deal. Chris, I don't know if you had something prepared or not for a tip of the week, but I'd hate to pass you by if you did.
No. My tip of the week was just if you're at your site, whether it's AM Directional, non-D, just observe, document, and pay attention, and do it at least twice a month. I mean, it's worth it. And if you can't convince your management that it's worth it, then do the math. Tell them, here's what's going to cost if we don't do it. And they should probably come around if you got the right person that understands the numbers.
Yeah. Good deal. All right. This has been a good show. Mark, it's always great to hear from you. I appreciate it so much. You're calling yourself nowadays a mentor of radio engineering, radio broadcast engineers, a mentor. People can look to you for advice.
I love it. People call and ask questions. It's like Radio Shack. They've got questions. I've got the answers.
Yes,
because I've been there before. I've done that before.
That's awesome. Good deal. Well, I'm glad they're asking you, because if they ask me, the advice would be worth what they paid for it. Hey, next week, I want to thank you, Mark Persons, for being with us. Watch for part 2 of his article, and if you haven't seen part 1, go look at it at radioworld.com. Best practices for AM directional systems. Chris Tobin has been with us as well from the New York City area. Next week, Chris, we're going to be live at the headquarters of the Telos Alliance. I don't know who my guest is going to be, but it's going to be, I'm sure it'll be high tech and interesting, as we're doing some cool things there at my employer. So.
Excellent. Look forward to it.
Yeah, me too. All right, we're going to go. I want to say big thanks, of course, to Mark and Chris, but also to Suncast, our producer. Got those pictures right up. Thanks for knocking that out for us, buddy. And also to Andrew Zarian, the founder of the GFQ network. And that apparently now is, he goes by Sultan Andrew Zarian. If you follow him on Facebook. We're gonna see you next week on This Week in Radio Tech. And don't forget, angryaudio.com, get your free cable. Tell them that you heard it on TWiRT when you order your adapter cables. I mean it. Do it, and make us all happy. We'll see you next week on This Week in Radio Tech. Bye-bye.